Muhammad Murtaza, and I'm here to teach you interference of light pattern, how interference is observed, what are conditions for interference of light, and what are types of interference. So if you like my video, please subscribe to my channel if you're new here, and also press the notification bell icon. Please like my video, please comment on my video, you can share it as well as to make me famous. Alright, let's get started. Interference of light that we're going to study now, and it's a very simple topic but a little bit twist also, but you have to concentrate each and every word I'm going to say, and you have to see my video from all over till the end. Okay, let's get started. Interference of light. Now what is interference of light? Let's suppose there are two light waves here coming from here. This is a light wave coming from point A, and this is another light wave which is coming from point B. For example, these two light waves are gonna interfere at some point. Okay, now let's suppose this light wave both light wave having same frequency. What does it mean? If this light wave is generating 400 waves in 1 second, so it means that this light wave will also be generating 400 waves per second. This is called frequency. The number of waves generated by any source per 1 second is called frequency. So if in case they both have same frequencies. Alright, amplitude, they both have same amplitude. This is amplitudes. This is the amplitude. For example, if this have 1 millimeter, if first wave have 1 millimeter amplitude, and the second wave also have 1 millimeter amplitude, so their amplitude are also same. Okay, their frequencies are same, their amplitudes are same. Okay, now their wavelength is also same. Now what does this mean? The upper portion of the amplitude is called crest, and the lower portion of the amplitude is called trough. So the wave starts from crests and ends up at trough. This is called wavelength, or you may say 1 lambda. So this wavelength is equal to this wavelength. I have not measured it correctly, but we have to consider it. Alright, they're both having same direction. So these 4 properties I'm going to tell you. They're having same frequency. This is the unit of frequency, nu. Having same wavelength, having same amplitude, amplitude denoted by x0, and having same direction. So they have all these 4 properties. These 4 properties I'm going to say in one name called phase coherence. So I'm going to name all the 4 properties. They having same amplitude, same frequency, same wavelength, same direction. I'm gonna say just a single word, phase coherence. It means 4 of those. So a light consists of same frequency, same amplitude, same wavelength, traveling in same direction, and they're gonna interfere. So when they're gonna interfere, a new light wave will be formed. But in 2 conditions. Maybe the new light wave will form having a greater intensity than the individual light waves, or if a new light wave is formed having a very low intensity, or might be possible that they both cancel each other and hence no wave is formed. So there are 2 conditions. If 2 light waves having phase coherence are allowed to interfere, now if they're gonna meet at some point, and when they interfere, a new light wave will be formed, which may be 2 possibilities. Either the intensity of the resultant white light wave will be greater than from individual, or might be less than from individual, or might be it will cancel each other. So there are 2 possibilities for interference of light. This phenomena is known as interference of light. So light is interfering here. Now we're going to go ahead to conditions for interference of light. So I'm gonna not write it conditions for interference heading, but it's written on the screen. Alright, conditions for interference. Number 1, light must be monochromatic. I know it sounds quiet, but what is monochromatic? Okay, this word, let's see what this word says. For example, there's a white light. This is a source of white light, and it is generating white light. So when I refract this white light through a prism, this light is gonna disperse into 7 different colors. Now I'm not gonna make all of those, but they are gonna refract through 7 different colors, starting from red to violet. So as you can see, red consists of wavelength 7 exponent minus 7 meter. This is the wavelength of red light, and violet consists of 4 exponent minus 7 meter. So they both have different wavelength, but as usual, red consists of single wavelength and violet consists of single. As usual, red and yellow consists of single wavelength, and more of all the 7 colors each occupy single wavelength. But if you take white light, it is not a single wavelength. As you can see, it is refracting and it is making a spectrum of 7 different wavelengths. So this white light is basically the combination of the mixture of 7 different wavelengths. So it is a combination of multiple wavelengths. A light which has a single wavelength is called monochromatic. So light must be monochromatic, might be with red, might be with violet, might be, and the best way to figure it out is you can take sodium bulb. So this bulb basically is a source for monochromatic light. You can make it through experiment. Or light must be monochromatic. The second condition is light must have phase coherence. Now I already told you what is phase coherence. Phase coherence means same amplitude, same frequency, same wavelength traveling in same direction. These both properties are known as phase coherence. So light must have phase coherence. And the third property is that superposition principle must apply, must be. Now this is the third property. It means that interference must be occupied. So let's go straight into another thing. There are 2 types of interferences of light. Number 1 is constructive interference, and number 2 is destructive interference. There are 2 interferences of light: constructive interference and destructive interference. Now what is the difference between them? Alright, as usual I told you, for example, there are 2 light waves, both having same frequency, same amplitude, same wavelength traveling in same direction. Now they have phase coherence, okay? Alright, now they're going to interfere, and let's suppose a new light wave is formed which is having a greater intensity. You can see the intensities of the individual light waves are actually added. Now the resultant light wave will be the addition of these 2 intensities, and a resultant light wave will be much greater from individual. As you can see, the intensity of the resultant light wave is greater. So I say this interference is constructive. In constructive interference, when 2 light waves having phase coherence are allowed to interfere, then the intensity of the resultant light wave will be greater than from individual, and that is why we call it constructive interference. Now what is destructive interference? If 2 light waves having phase coherence are allowed to interfere, and when they interfere, might be the intensity of resultant light wave will be much less than from individual light waves, or might possible that they will cancel each other, and hence no light wave is formed. This is why it is called destructive interference. As you can see, the word constructive arises from a smaller word construct. Construct means to build, to make something much more bigger. So if you can see, these 2 light waves add and make a great intensity light. But in the other word, destructive comes from a word destruct, means to demolish, to finish, to vanish. So these 2 light waves just demolish themselves because they were destructive interference, and hence no light wave is formed. Now the first property of constructive interference and destructive interference is that when 2 light waves interfere, might be the intensity is greater, so it is constructive interference. Might be the intensity is lower, so it is destructive interference. Now we're gonna go heading to second properties of the constructive and destructive interferences. Alright, for example, light wave. This is a first light wave and this is second light wave, for example. So they both are having phase coherence, means they will have same frequency, same amplitude, same wavelength, and traveling in same direction. They're both having phase coherence. Alright, now going to interfere, and what will happen? A new light wave will form that has a much greater frequency than from individual light waves. Alright, what happens? Basically, what happens? I already told you the upper point of amplitude is crest, the lower point of amplitude is trough. So this is crest, this is trough, this is crest, trough, crest and trough. Now I'm not gonna make it crest, trough. Alright, all marks located. As you can see, in constructive interference, one thing is more common. The crest of the first light wave is moving simultaneously with the crest of the other light wave. You can see crest and crest are together. Here you can see crest and crest are together. There and there you can see, this is observable that crest of the first light wave is moving with the crest of the second light wave, and at this point you can also see that trough of the first light wave is also moving with the trough of the second light wave in all the conditions, as if the crest and now if the crest of the first light wave is moving simultaneously with the crest of the other light wave, then what is happening? The intensity is much greater than from individual. That is why we are calling it constructive. So constructive interference depends upon crest and crest. When crusts and crusts are moving together each other, and all trough and trough are moving together with each other, then the interference is said to be constructive interference. So the 2 points are basically no. What is the point? Number one is that if the two light waves are interfering each other and a light wave having a greater frequency is observed, then the interference is called constructive. And when the crest of the first wave is moving with the crest of the second wave, then the interference is constructive. There are two main basic points that we have studied. What is the third point? Alright, let's go to destructive interference. To destructive interference. Now, what is destructive interference? Let's see. For example, let's consider another waves. For example, this is first wave and this is second wave. Here now. There are two light waves which are generating at the same time, but both having phase coherence, and now they're going to interfere. And what will happen now? A new light wave will form having very low frequency, very low intensity, or might be no light wave is formed. So we just you're not gonna remove it. Most of the times no light is formed, and very little bit times some light is formed but having very low intensity. So their destructive interference. This is crest and this is trough, crest and trough, crest, trough and crest. Here we go, another crest, trough, C, D and C and T. So here we go, let's see what is happening basically. In the first condition, crusts and crusts are moving together, but here you can see crust is moving with trough. Trough is moving with crust, crust, trough, trough, crust, and you can see these are moving together. In the first condition, you can see the crust is moving with the crust and trough is moving with the trough, but here this is reversed. Crust is moving not with the crust but with the trough, and trough is moving not with the trough, with the crust. So if two light waves, if the crust of the first light wave moves with the trough of the second light wave, then the interference is said to be destructive interference, and hence no light will be observed, or maybe a light observed but will having a very low intensity than individual light waves. Alright, in the destructive we have understand what is constructive and what is destructive interference. But the third main point that we're gonna understand is very important for most of the experiment having held by for the interference of light. For example, Young double slit experiment, Newton rings, X-ray diffraction grating. These are Michelson interferometer. These are the experiments which contains interference of light. So before studying these experiments, we have to understand what is interference of light. Now we're heading to constructive interference again. Why? We're gonna develop an equation using constructive interference. How? Let's see. Okay, this is our first light wave generating, and this is second light wave which is generating. Okay, now they're gonna interfere, and a light wave will observe, which is having a great intensity, so then interference is said to be constructive. As you can see, the crust of the first light wave arrives simultaneously with the crust of the second, and trough is moving with the trough. So, if I just said you in the first wavelength, I don't need to mention all of those. So this is crust and moving with the crust, this is trough moving with the trough, and interference is now constructive. Okay, what is happening? As you can see, the second light wave is moving covering much more distance than the first. How much? If I subtract the distance of the first light wave from the distance covered by the second light wave, I just subtract this distance. Now what do we get? This is, now I'm gonna call it path difference. So path difference, now definition of path difference. What is path difference? Path difference is basically if a light wave covers much more distance than the first light wave, then this much more distance that the second light wave has covered from the first is called path difference. So this is path difference. So here, as you can see, this is crust and this is trough, and wavelength starts from crust, ends up at trough. So this is one wavelength, 1 lambda you can call it. So the path difference here is 1 lambda. I'm gonna write it down, everything, each and everything I'm gonna tell you about. So in the path, as you can see, when the path difference is 1 lambda, which type of interference is it? It is constructive. Why? Because crust and trough are moving with each other. For example, there is no path difference. For example, the light starts from here. So you can say the path difference is 0. Or might be you can say the path difference is 0 lambda. No problem, no differences between 0 and 0 lambda. Both are equal. So as you can see, the path difference is 0 lambda. And now interference. What kind of interference is there? It's still the constructive, because crust and crust are moving with each other, and same in the trough and trough. So when path differences is 0 lambda and 1 lambda, the interference is constructive. Let's say this wave is starting from here. Let's assume that this wave is starting from here. This is crust and trough. This is crust and trough. The distance between crust and trough is 1 lambda, and same here 1 lambda. Now if I tell you to calculate how much path difference is it, you will add, first of all you will subtract first wave from the second. Now this all has been subtracted, now this has been remained. So if you can see, this is all path difference. So if you add both of those, 1 lambda plus 1 lambda, what do we get? 2 lambda. So if you can see, when path difference is 2 lambda, what is the interference? It is constructive interference. If I add one more wave here and just assume that I just started a light wave from here, is still what kind of interference is it? It is still constructive, because crust and trough are moving together. So this is crust, this is trough, and 1 lambda plus 1 lambda plus 1 lambda equals to 3 lambda. If I add one more wave behind, it will be 4 lambda, it will be 5 lambda, and it will goes to up to m lambda, where m stands for 0, 1, 2, 3, 4 and so on. So as you can see, when m is equals to 0, then whole factor is 0 lambda. When m is equals to 1, then it is 1 lambda. When m is equals to 2, I put 2 instead of m, there will be 2 lambda. There will be 3 lambda when m is equal to 3, and when m is equals to m, then there will be m lambda. So basically, when path difference becomes m lambda, then the interference is said to be constructive. Now we have developed a general equation for interference of light. This equation belongs to constructive interference, and we can say it when interference, in constructive interference, usually the path difference is m lambda. Not usually, always. Path difference is always m lambda in constructive interference. Alright, now heading towards this destructive interference. This is the equation that we have to develop, and now I hope you will understand each and everything that I am teaching you. Now this is most important topic, destructive interference. For example, this is a light wave. Now this is first light wave and this is second light wave. Alright, now I'm gonna make a line so that it might be visible. As you can see, crust and trough are moving together with each other. So, and trough and crust are moving together with each other. So you can see the interference is destructive, hence no light will be formed. If I ask you what is the path difference of destructive interference, you just subtract this whole wavelength, whole distance with this. This is the path difference. So as you can see, this is crust, this is trough. Wave starts from crust and ends up at trough. This is whole wavelength. But if you can see, the half of the portion is subtracted and half is remaining. So half wavelength is remaining. So the path difference here is half lambda. I'm gonna write it down as half lambda. Now the first condition, first path difference is half lambda. Alright, now I'm gonna add another wave and just assume that I have started this light from here. This is crust, this is trough. Still crust and trough are moving together, so interference is destructive. Now let's see what is the path difference. This is half lambda and this is crust, and the distance between crust and trough is 1 lambda. So 1 lambda plus half lambda, let's calculate it. 1 plus 1 lambda plus half lambda. You can take LCM. 2 lambda plus 1 lambda. 2 lambda plus 1 lambda is equals to 3 lambda divided by 2. Now if I add one more wave here, still the interference is destructive. This is crust, this is trough, this is more 1 lambda, and now I'm gonna add 1 lambda plus 1 lambda plus half lambda plus 1 lambda here. Now 1 lambda plus 1 lambda, 2 lambda, and with 2 lambda plus half lambda is equals to 5 lambda. As you can see, when path differences are half lambda, 3 lambda divided by 2, 5 lambda upon 2, the interferences is this destructive. When I say path difference is 7 lambda by 2, interference destructive. When I say path difference is 9 lambda by 2, interference destructive. What is happening? Basically, these are the path differences for destructive interference. Now let's generate an equation for destructive interference. Alright, here we go. When if I say 1 upon half into lambda, or I add 0 in it, there will be nothing. I can do it easily. Still I will get the answer half lambda. Alright, when the path difference was 1 lambda plus half lambda, what was happening? What happening? Basically, I took the lambda. There are two factors, both of them having common lambda, so I'm gonna take out. So 1 plus half lambda I have taken out as common, so there is another equation. Alright, when interference was half lambda plus 1 lambda plus 1 lambda, 1 lambda plus 1 lambda plus half lambda, what was happening? Basically 1 plus 1 2, and all three have lambda in common, so I'm gonna take lambda as common. So what is happening? When there's a when it is 0, then it is half lambda. When it is 1, then it is 3 by 2 lambda. When it is 2, then it is 5 by 2 lambda. And you can say that when it is 3, then it is 7 by 2 lambda. When it is 4, then it is 9 by 2 lambda. You can calculate it. You can easily calculate it will be the answer. And when you say that it is m plus half into lambda, what kind of interference that this is destructive interference? So we have developed a general equation of path difference for destructive interference. So we have developed two equations. I'm gonna erase all of those. I hope you would like my video. When path difference is m plus half into lambda, then the interference is destructive. When path difference is m lambda, then interference is constructive. There are two conditions for interference. So interference might be destructive, might be constructive, all depends upon path differences. When path difference becomes m lambda, interference becomes constructive. When path difference becomes m plus half lambda, then interference becomes destructive. So there is the end of my lecture. This is whole interference of light. If you like my video, please comment, please like my video, and if you are new here, please subscribe to my channel. Please subscribe to my channel and press the notification bell icon. And you can share my video also if you don't mind. So take care. Allah Hafiz.